excited to be here, post-COVID and all, and it takes getting used to it, because still sometimes having a hard time remembering to put on my pants before meetings, but today I'm good, so I think we can begin. Let's see if that works. Yes, a little bit about me. I've been around for 20 plus years, yes, even before Spring. Been talking Java ever since. Worked in enterprises, small companies, startups. Lately I've been doing more work on the architecture side. I'm leading a team of architects in AT&T, and we're doing a huge endeavor of modernizing literally thousands of applications from on-premises to the cloud. And they're also adding some serverless and innovation along the way. You can check me up in Medium. But that's not what I'm going to talk about today. Today I'm going to tell you a story that happened in the place I worked before AT&T. I'm going to talk about it some more in a second and give you the background. There we encountered a problem, a real-life problem. And I know that usually in conferences, the sessions are how can you start a Spring Boot service in 5 seconds, or deploy everything to Kubernetes in 3 clicks, and all that. But what happens next, right? After you doing all that and start building a real-life application, going to production, start to collaborating with your team, you find out the real problems that no one's talking about in conferences. No one's want to ruin the mood. So I'm going to talk a little bit about that and how we solved the issues we encountered. And later I'm going to leave a few minutes, if possible, to hear about your side. How did you, if you encountered the same issues, I believe you did, and how you handle it. Because, for every problem, you can have several solutions. And one of the great things about coming to a conference and meeting people from all around the world is seeing how others are encountering the same problems and learning from them. So I hope I can show you something new today, and maybe you can show me some stuff later. So let's start. A little bit about the background. I hope you can hear me even when I'm not looking at the microphone. This job was in a government office, and I wasn't a government employee, but they brought us in to innovate, right? I don't know how it is in your countries, but where I come from, government offices are, let's say, a little bit behind technologically. They had huge monoliths, small monoliths, mainframe-based applications, non-mainframe-based, and they wanted to innovate. So we picked up a project which we started to write from scratch. And of course, we chose Spring and Java to do it, otherwise I wouldn't have been here. And we also wanted to show them a new architecture, a new methodology, and we chose to build it as a microservice-based application with Spring Boot. Obviously, this is nothing new these days. I think that microservices are the common choice for architecture these days. But we did want to use multiple programming languages. For example, one of the microservices could have used some or run some machine learning models. We thought about Python. Most of them were Java, but we wanted to keep that open as an option, and maybe even reuse some of their current modules. They had some C# code that we thought that they might want to use or reuse. And we started talking about the advantages of microservices. As you can see here, I think you know it, independent deployments. That was very important because they released a version once every 6 months, if I recall. and we wanted to show them how they can release versions all the time. And the scaling was also an issue, that some of the modules need more scaling than others. And before we came, they just bought more and more huge machines and spent millions. Again, government office, it's not their money. So we wanted to show them something different. But when you come to choose an architecture, you got to remember that there are downsides for everything, right? I can talk a little bit about the multiple programming languages because it's a real life issue in Coder. Think about a few years ago, if your star developer comes to you, or maybe you're the star developers, and you come to your manager and tell them something like, Ruby on Rails is going to be the next big thing. It's going to be the Java killer, another Java killer. I want to write this new microservice in Ruby. And you as a manager thinks, okay, this is my star developer, he knows what he's talking about, and I don't want him to leave, and maybe this is the future, I trust him, and he writes this microservice in Ruby. Everything's okay, but years pass, and Ruby passes on as well. And the star developer is also leaving for another shiny startup, and you're stuck, right? So this is a real story. And besides, if you have many microservices, you push up the complexity. And soon I'm going to talk about this specific problem we had, but complexity is not just this problem, it's all over the board. You got to maintain databases because every microservice got to have its own database, and these might be different databases, graph database for one service, MongoDB, I don't know, Neo4j if you use graphs, MySQL, whatever the team wants, you give them, and you end up with multiple databases, multiple technologies. You got to maintain multiple code bases, multiple CI/CD chains, and not to mention the debugging and tracing. I'm sure that at least some of you encountered that. So these are the downsides, but nevertheless, we went for it because we believed it can help us in many other ways, but we remember the downside as well. So this is like a general sketch. I couldn't bring the real services map due to confidential information, but it looks like that, right? Some gateway to route the services. I'm going to talk about that a little more in a sec. And the services running happily with their own databases. Everything looks nice. And like I said, we chose Spring Cloud, right? I think it's still is the most common framework to use if you want to build microservices in Java. It's been around for a while, as you can see here. I counted 33 items there that you can play with all around the microservices needs. And it's a great library and evolving all the time. Now, we chose to use some, let's call it helper services. I know that you can do without them or without some of them, but I think that two are essential in almost every environment. One of them is the discovery service. We chose Eureka as a part of the Spring Cloud libraries. I hope you still remember it was donated by Netflix with some other libraries to Spring. And it can help you in some real-life issues you encounter. For example, how do you find the service, right? If you have the service by name, you don't use, of course, the URL or some IP service, use the name, so how do you find it? And servers are shutting down and coming up again, maybe in a different IP. And sometimes you have several instances. So using a discovery was a good idea, and it helped us a lot. This is how it looks like if you don't use, I don't know how many of you use Eureka, but this is how it looks like. We're going to see that later as well. And we needed a gateway, right? Someone has to know about all these services and route the request because, for example, you don't want the UI to know the exact structure and location and where the instances are running. So you hide it from everyone. You can add security in the entry point. And this is basically a good idea to use. And we use Zool. That was the hot gateway at the time. I know that you're also young, but do you know why Zool? No one. Okay, so at least I could innovate in one thing. Right, Ghostbusters. So, yeah, that was a hit at the time. And there was a character that looked like that. And its name was Zool, and his title was the Gatekeeper. So that's why they call it Zool. So at least I innovated one thing here today. So that was the two must-have services. We used two others as well. In case you don't use them, I recommend that you look into it. One of them is the configuration service of Spring, because you don't want to maintain dozens of configuration in case you have many services and you want to apply, for example, the URL of the discovery service, URL of Eureka. So if that changes, you don't want to pass on every service and change its properties file. You want to keep it in some central place. And the Spring configuration service can store the configuration in a file or a database, but some version control is the best place to put it, as you can track who changed what. You can go back to a specific version. You get better management. And that is great. I recommend that in case you don't use it already. And think about dozens of services. Someone needs to manage that, or at least have a global view. Easy way to do it. And at the time, the admin for Spring Cloud was the obvious choice. Now you can have other services, but it's still a good choice. It shows you the health of your services. For each machine, you can see some consumption, CPU, and you can even see logs. Again, think about lots of services. Later, we sent everything to Elastic, but at the time, that was a good choice. And again, still, if you want to look at one services log, this is an easy way to do it. So we ended up with this environment, and we started to build the application. And as you can see, we started with 2 services and some helper services, but the number of services went up and up and up. We ended up with dozens of services, and then we encountered the problem that I wanted to talk about today. And the problem was related to developers. How do you develop and test? And I'm not talking about JUnits that you can run locally on your machine and doesn't affect anyone. That's easy. Talking about integration tests, and if you're a full stack developer and you work with the UI and the backend, sometimes you change stuff, you want them to be reflected in the UI, you want to do it fast. How can you do it? So we had basically, at the beginning at least, 2 options. Option A, run everything locally, and I'll explain in a second. And the other option was to have a central environment and only work on 1, 2 services locally, the services that you develop currently. So this is how it looks, or might look. If you're working locally, everything is on your machine. Right? Both the microservices of the application and the helper services, and if you're full stack, it's also the UI. You work from IntelliJ or Eclipse or whatever, and everything is contained in your machine. The other option is to run everything in a central environment, and every developer will only pick one or at most two services and work on them locally, and the other will come from a central environment. And of course, in this case, everyone's sharing the same discovery service, right? Because they need to find the services in the central environment. So we thought about it some more and tried them both, and we found out that both options have their downsides, of course, right? To run everything locally, I don't know if you encountered that, but you can run, depends on your service. Again, if you're doing an empty microservice that you learn in one of the sessions here, it doesn't take too much memory or resources. But if you're doing real life microservice with maybe a database attached and some logic, it might take some more resources. So you can run 5, 6, 7, depends on your machine. At one point, you run out of memory, right? So it's an issue we encountered. And not to mention building the environment all the time, because remember there are at least one team, sometimes maybe even a few teams working on the same application. They're all updating the microservices, changing APIs, adding some stuff, breaking some stuff. You have to fetch everything and build everything in your machine. So that also took time, not to mention configuration that you have to track, and new parameters, new properties are added all the time, and databases that have to run somewhere, and you don't want to collide with others, so you have to maintain those as well. That can be a problem, right? So why not central? First of all, someone has to maintain it, right? If you run locally, you are responsible, and if there's a central environment, someone has to build the environment, check the version, handle issues, right? There are always issues, but that's the minor problem. The larger problem was avoiding collisions, right? Because if we're working on a central environment and we have service A in the central environment, and I'm currently developing service A locally, where will a request be routed to? My service A or the central environment service A? That's an issue. I cannot live with a situation where only some of my requests are coming my way. Not to mention maybe other developers running service A locally and adding to the party, and we have more collisions and issues as well. So that wasn't a good choice either. Later on, we could have gone to the cloud, right? Easier to set up environments, no hardware needed, or if you need no hardware, purchase needed. If you need more machines, more virtual machines, you can just get them, scale to infinite, everything's cool. But A, you still have to maintain it, and B, it's gonna cost you. Think about, I don't know, 100, 200 developers, each one pays a few $100 a month for his environment, sometimes more if you have large resource requirements. It becomes a big sum you have to pay just to have some environment for the developers, right? Sounds like too much, maybe even too complicated. And one last thing that's maybe relevant to government offices and maybe banks or other legacy organizations, sometimes you cannot do stuff in the cloud due to regulations or confidentiality, or for other reasons, you just can't. So it might not even be an option. And even if you're thinking, I can do everything in Kubernetes, start an environment in 1 second, maybe you can, but you'd still have the same issue, right? If it's in the cloud, you're going to pay for it. If it's locally, someone has to build it, maintain it, and you still have the issue of collisions. So none of these options worked well for us. So we were determined to solve that and thought, what will a good solution will look like, right? We came clean to the table, very optimistic, and we said those things. We want the developers only to run the services, the microservices they work on locally, right, to save resources. B, we wanted to use a central environment for the other services, so every developer can work locally on his own services and use the other services from the central environment. And using magic or some other way, we want the developers to avoid collisions, right? Looks great, but how do you do that? We thought about it and came to this solution. First of all, the first bullet was given, right? Because if I want to work against the central environment, I have to use some global discovery to know about the services in the certain environment. And if that's true for every developer, all developers are working with the same discovery service. That was given, that was the easy part. Now for the smart part. The local services I'm working on would not register under their own, their regular service name, for example, the payment service, but they will have some unique name. And the uniqueness, so to speak, came by using the developer's machine name, right? So if I'm working on my machine, the service will be called mymachine.payment and not payment. This enables us to differentiate those two payment services by name between my local payment service and the payment service from the central environment. And we wanted that to be done automatically, and that was easy to do by implementing a Eureka bean that can configure how the Eureka server sees you. I will show you that in a second. And we needed one more thing, someone to route the requests, and we extended Zool. By the way, nowadays, Zool and some other Netflix services have gone into maintenance mode, and now the recommendation is to use, if I'm not mistaken, Spring Cloud Gateway, but it's the same thing. You can extend the Spring Cloud Gateway the same way you extend Zool, so same logic applies in both cases. And here we did the routing. We checked two things. If A, the request came from my machine, and B, you have the my machine prefix to the requested service, because we have a requested service X. If those two conditions are met, we route the request back to my machine. Otherwise, we send the request to the central environment, one of the central environment services. So this is done by the central gateway. Sounds nice, and maybe it's a little bit confusing, but I'm going to show it both in graph, both in code, and I'll demo it in a second, so no one leaves the room unless he fully understands the solution. Okay, so that was the setup. Local machine of a developer, IDE, maybe a UI, and some services working on. And the central environment is using the gatekeeper and the request coming in. If the request is coming for service A and from my machine, and there is a service A running on my machine, the request will be routed here. And if the request is for service B and I don't have a service B running on my machine, it will be routed to the central environment. That is the idea. And thanks to Spring, got to thank Spring, after all, we were in a Spring conference, it was very easy to achieve, right? in the Eureka configuration bin, we did one small thing. We build up the new name based on the current service name and my host name. This bin runs on every service that's running on my machine that I want to work on. And I'm setting up the name when I register to the new name. So the payment service on my machine will be registered as mymachine.paymentService. I'll show you that in action in a second. And the Zool filter is even simpler. We have the machine name, who called this service, where did the request come from, and we have the requested service based on the URL. So we build up the new name, and we check if among those services running on the discovery that we're working with has this service. We change the context of the request. It will no longer go to payment. It will go to mymachine.payment. Okay, that's it. Very straightforward and solves the problem. But don't believe me. You don't know me. Why should you believe me? I will show it to you. Okay, so I've built up a simple environment. Let's start with our Eureka. I hope the fonts, we look at it, it's going to be large enough. I'll start the gateway. Okay, so the gateway currently doesn't have any services to route stuff for. And I have two services that identify themselves as service A. Let me start them. It's going to take a second because I'm not using the Graal VM. When I access the service directly, I've changed the response between the so-called local service and the remote service A. This is one, imagine a central environment. This is running locally on my machine. And if this is the gateway, you see it routes to service A by URL. And now I expect if I start pinging the service, I expect that the gateway will use the embedded load balancer and access my local service and the remote service in some round-robin methodology. Let me refresh and see if that's true. Yep, that's true, which is great. No, which is not great, right? Because I don't want that. Think that I'm working on service A and working with this gateway. Half the request will go some other place. Bad, right? And if we look at the discovery, the Eureka screen, we can see why that is happening. It has two instances of service A running on my machine. So that was the problem. So that's bad. Now let's erase this bad environment and start on a good one. To achieve a good environment, I'll just turn on two flags. One is running on the gateway, and let's see, this is the filter I was talking about. It's a Zool filter. Again, if you use Spring Cloud Gateway, it has filters as well, can be extended. And basically, it does what I showed you in the slide. Builds the new name and check that if I found the service instance by name, by the new name. I'll change the context to this new service, meaning routing to my machine. Okay, so let me start executing again Eureka and the gateway, and now the services. But since we develop this service, we have to turn this on. This can be done automatically, of course, but for demo purposes, I needed a flag to show both options. And this service has the Eureka config. I mentioned setting the new host name. So I'll run it as well. Let's give it a second and refresh everything. Okay, what do we have now? Now we don't have two instances of service A, although I am running service A twice, right? But one of them, since I've turned on the flag, which activated this bin that changes the registration in the discovery, now we have localhost.service A, which is what we wanted. Enables us to differentiate between these two services. Let's check them locally, because if they don't work locally, routing will not work as well. And what do I expect to happen now if I call the gateway? Can someone tell me? Do I expect to get a response from my local service or from the remote service? Local, right? I hope everybody said local. Let's assume you did that. Right, now if I refresh the request, I don't get a response once from the local service and once from the remote service. All the requests are routed to my own local service. Now, that was a demo, but think on a larger scale. Now, we can have an application with hundreds of microservices, which obviously won't fit inside my local environment or will be too costly to run multiple times in the cloud, for example. But I can have one central environment running all of those microservices, and still, as a developer, I can develop one or two services locally and work against the central environment without causing any collisions. My requests will be routed to my services. All other requests will be routed to the central services. And everybody will be happy. If you have questions, you can ask me now, unless I have some questions for you. But start with you. Yes, but the second, the microphone will come to you. I guess this is for recording, because I can hear you just fine.
Just raise your hand. Who was first?
Thanks. That sounds quite nice. My question is, how do you do it with messaging, like Kafka?
Right. This is a great question. We thought about it. We didn't use Kafka. We used other message queue. We used RabbitMQ, if I remember correctly. But you can have the same methodology, right? You can change name of queues or add some properties in the header of a message and make it route to the proper listener, right? Same idea. Different implementation, of course, depends if it's Kafka or RabbitMQ or some other message brokers. I think it would be easiest way to do it to use some Spring infrastructure like we did here for the discovery in Zool, but same way, if you're sending a message, if you want to receive your own messages, listen to not the general queue, some specific queue, or filter by header. And when you send the message to you, which is obviously the case, add this header or change the name of the queue dynamically, of course. Now, I will answer the unquestioned question. How do you do it if you don't initiate the request, right? If you have multiple services and service A calls service B who calls service C, and you still want to have this behavior, for example, if you run service C on your local machine, same idea, right? The same way that distributed tracing libraries are working. They add some headers to the HTTP request, and therefore you can track the request between multiple microservices and have like a global picture of the path of the request. You can have the same thing here, right? Because you are the initial initiator, so to speak, from the UI or from some test that you wrote. So you can add this header, and if the infrastructure of your microservices acknowledges this header and knows what to do with it, for example, pass it forward and check at each entry point to apply the same logic as the gateway, you can have this routing to your own machine at any point from every service. Okay, so this is the idea. You can apply it in various configurations, various libraries to achieve the same thing.
Hello. We went through the same journey, I think, as you guys were. We are now in the paying for the environments for everybody, and which is not ideal. We are exploring a solution using telepresence, which is basically doing what you just mentioned, basically, because we don't use the gateway for every service-to-service communication, but you basically have in the cluster, so it's a proxy on top of every microservice, and then it intercepts to your local. Mm-hmm. So have you guys, if you're using microservices, have you explored that one?
I've read about it, but it was after our solution. But think about what you just said. A, you're paying for multiple environments, and B, you're going to pay for another product. Maybe you don't have to. You can add a few lines of code and achieve the same thing.
Yeah, just one more question in that sense. So what I didn't get straight is like the gateway needs to be running locally on your machine. How are the services running remotely, accessing your machine network? Do I need to expose my laptop within the networking here? It's not, if you could...
Okay, I hope I understood your questions, but the gateway, it can run anyway, but easiest thing to do is to run it on a central environment, one, and all the UIs, the browsers can be accessing it, and B, we ran on the same subnet. We developed locally, remember, government office, so there was no exposing machines or hybrid environments between the cloud and locally. But again, you can achieve that easily, either exposing directly, remember this is development environment, so it may not be that bad, or through some bastion or some other way to make this communication possible. But once you do, you don't care where everything is running.
Hi. I want to ask, when you're developing locally, do you also spin up the database locally as well?
What we did was, the short answer is yes. If I'm developing service A, I was running the database for service A locally, because I wanted to test with some data or run some specific scenarios. You don't have to.
Yeah, and I have a follow-up for that. So when you have the local database and let's say some other microservice has a link to some entity you persisted in your local service, that link no longer works when your machine is turned off or something. How do you handle this garbage data?
That's a great question. And when you collaborate with other developers, we came up with some methodologies not interfering one another. For example, some of the stuff we tried was separating the data by prefixes, or in short, we tried to separate the data along the databases for every microservice between developers. So you won't try to find an entity that I've created locally on my database. We also cleaned all the database for testing regularly and fill them with the initial data that everybody could see. So you're right, we had to take care of that. It doesn't come for free, and yes, if you're not careful, you can start losing data, and I'm going to look for data that's not there, or there can be duplicates, and people can interfere with each other, so you have to handle that as well. If you don't want to pay for multiple separate environments in the cloud, you want to save sometimes a lot of money, you'll have to be smart about it, yeah. Okay, if there are no more questions, thank you guys. It was lovely being here.